Yarra Ranges Council opened a biochar facility in Listerfield in 2023. The facility was partially funded by the state government through the Growing Suburbs Fund. Through a public tender process, Earth Systems was selected to deliver the pyrolysis machine, and Yarra Valley Ecos was selected to run educational outreach programs and demonstration trials. Yarra Ranges Council, as the owner of the facility, receives royalties for the biochar that's produced, and the revenue from carbon credits is shared between the council and the operator of the facility, Earth Systems. At council, we're planning on integrating biochar use into our operations. This includes revegetation projects and tree plantings on public land. By using biochar, we can improve the health and resilience of tree plantings, reduce potable water usage, and sequester carbon within the soil for a more resilient and sustainable Yarra Ranges.
I'm Dr. Adrian Moffat. I'm the inventor and developer and the builder of this technology you can see behind you. So we've got a fully integrated system here where we receive our wood chip over here from local tree contractors and arborists, commercial only. So we get a really clean biomass delivery supply chain from the local community, which is really good. So it's all locally supplied, and so low carbon miles for the feedstock itself. And otherwise it's a wasted resource, so we're beneficially using local biomass resources from around the Yarra Ranges. Then what we do is we put the biomass through various conveyors, and we have a magnetic separator to clean out any metal as well. Because the biomass comes in so green, so we've got an integrated dryer as well. So we use the waste heat from the process to run a pre-dryer, and that reduces the moisture content of the wood chip before it enters into our char maker. So it comes out of the dryer and then it goes through a double airlock system and then enters into the char maker pyrolysis kiln, and then it goes through a very carefully controlled low oxygen, high temperature environment for about half an hour. It spends about half an hour in the kiln, and what that does is it pushes all of the smoke, all the volatiles out of the wood and leaves only the carbon behind. So what we're doing is we're chasing the carbon and we're pushing everything else out except for the carbon. So it spends about half an hour in the kiln, and then once it comes out of the kiln, as I said, we've pushed everything else out except for the carbon, because the carbon-to-carbon bonds are very strong. We're aiming for that 500 degrees in the biochar itself. That produces the best properties for surface area, cation exchange capacity, and also fixed carbon as well. The advantage of going to that temperature is that at that temperature, the carbon-to-carbon bonds are very strong. It's very stable in the soil. So that carbon is now locked up for 1,000 years or more, and it's bio-unavailable in the soil. And so that's the difference between, say, our char maker technology and, say, a charcoal producer, which is much lower temperature. Once it comes out of the kiln, it drops into a water auger, goes through another airlock system, and then drops into a water auger, and where we quench the char, and then we automatically dose the wet biochar into various bulk bags for export to market. When required, we have a post-screening system as well, where we can screen the char into different size fractions if needed for different soil applications, depending on what customers require. So look, the char maker itself is quite a sophisticated technology. It's been around, it was invented by myself and a colleague in 2010. So it's one of the earliest pyrolysis technologies around. It's patented, and it's a completely computer-controlled technology and uses various banks of augers to very slowly move the biomass from one end of the kiln to the other end of the kiln in a very low oxygen, high temperature environment. And what the machine does is the biomass goes in, we heat it up, it releases the volatiles from the biomass, the smoke. Those volatiles are actually combustible. We pass those volatiles through to our thermal oxidizer, where we combust them to create heat. We then recycle that heat back into the kiln, and then that provides the heat to run the kiln and also to preheat the incoming feedstock that's just been entered. So in that regard, the entire process is self-sustaining. We use a small amount of diesel to get the system up and running in the morning, and then as soon as possible those diesel burners are turned off, and then we run on wood gas. So it's a wood gas technology, and that runs everything. It runs the thermal oxidizer, emissions control, the kiln itself, and the preheat. It runs. We use the waste heat for the dryer as well. So everything runs on the energy of the feedstock, and it all comes from the kiln. That's how we do it. It is a thermal technology. Like all thermal technologies, there are emissions from this process, but we've gone a lot of effort to achieve best practice globally, so that we treat the emissions so that as the emissions come out of the stack, they are as low as possible. So we have a multi-stage system for decomposing the volatiles from the process. We use a thermal process. We've got scrubbers as well. The dryer itself and the wood chip actually acts as a bit of a scrubber as well. We've got extremely low emissions, which has been NADA stack tested here. We've done NADA stack testing in Hong Kong, in Europe, in New Zealand. So globally, this is a best practice technology. It's been assessed by the Victorian EPA. The advantage of pyrolysis is you can extract multiple benefits from the biomass. So rather than say combustion, you just get heat and that's it. With pyrolysis, which is a low temperature process, we can get biochar, we can get heat, we can also get liquids as well. So we've got a bioliquids recovery system where we collect and condense and clean and produce a wood vinegar product. So that's what we get from this system. We get low emissions, we get heat for the pre-dryer, we get the biochar, and we get the bioliquids as well. So biochar is a very beneficial product for soil. Mostly it's used as a soil ameliorant. So it's basically a high surface area fixed carbon substrate for soil. So it's not a nutrient-rich product, but what it does is it creates a surface area and a substrate for beneficial soil microbes to grow on. So I've heard people describe it as an apartment building for soil microbes. They move in and they have a wonderful time in there, and then the plant roots then find the soil, then find the biochar, and they interact with the beneficial soil microbes growing on the biochar, and they wrap their roots around it, and then that helps the plant interact with the soil. So it's almost like a catalyst for soil, in that it helps interact with the soil microbes and interact with the nutrients in the soil as well. It's 1,000 years plus in the soil, so unlike all other products, once it's in there pretty much forever. It has excellent water holding capacity. It's not as good as water crystals, but it's up there. But as opposed to water crystals, it has good water holding capacity and also available water capacity. So when plants try and access the water out of biochar, they can get it out. So it's excellent for drought conditions. And same with nutrients as well. It's great for holding on to nutrients in the soil and making that available to plants when needed.